filling in just a few sentences at the top of our page. This is going to really guide the steps that we're doing in solving these equations. So for each problem, we're going to begin by identifying what is the least common denominator, or we'll call it the LCD. And what that represents is it's going to be the smallest number or the smallest expression. So expression just means that it might involve a variable. The smallest number or expression containing all the factors of the original denominators. All right, so let's just pause here and see what that would look like to find the least common denominator in the context of our first problem. So if we take a look at what we have in our denominators, we see that we have 5 and a 2 on the left-hand side. We could factor the 10 into 5 times 2 on the right-hand side. So notice that the most number of 5s that a single denominator has is 1 5. So we're going to put 1 5 in the LCD. And then the least number of 2's that a single denominator has is 1 2. So we're also going to have a 2 in the LCD. All right, so that contains all of our factors that were in our original denominators. Now let's see what we're going to do with this. We're going to use the LCD in the context of solving rational equations to cancel everything from every denominator. And here's how it's going to work. We are going to multiply everything on both sides by the LCD. Because since this is an equation, as long as you do the same thing to one side that you do to the other side, it's okay. So this is how we know what to multiply by. So it's going to look like this. On the left-hand side, it'll be 5 times 2. We'll get multiplied by the left-hand side. We're also going to multiply 5 times 2 by the right-hand side. Now you'll notice that on the left here, I did put parentheses around this part because these pieces are being added. It's not just the first one that gets multiplied by 5 times 2. They're both going to get multiplied by 5 times 2. So it's kind of like the distributive problem. All right, one other thing here I want to add to this 5 times 2 that we put on either side. Well, I want you to think of that 5 and that 2 as being in the numerator. So it's really like 5 times 2 over 1. And that's important for us to know where these are, because when you think about this multiplying by the first fraction of 4x over 5, notice how this 5 in the numerator here can cancel out with that 5 that's in the denominator. So we know that that canceling is only allowed when things are being multiplied on the top and bottom, and you have to have one factor on the top that's exactly the same as another factor on the bottom. So those are going to cancel. All right, and so actually, let's see how I wrote this out. Here's maybe an even nicer way to write this out. You don't have to erase yours completely. I'm just going to write off to the side down here. Because every single part is multiplied by 5 times 2 over 1, we could actually separate it like this. So down below, it's kind of like this is the result of doing the distributive property. Put it over here. All right, so everything that's in parentheses, those were the original components of the original equation. Here we're just showing that both parts, every single thing on both sides, is getting multiplied by that 5 times 2 over 1. All right, so now when we think about actually doing some canceling, like for this first part here, let's go ahead and cancel out that 5 on the top with the 5 on the bottom. And that's just going to leave us with 2 times 4x on the top. So let's actually write that as 8x. All right, for the next one here, the 2 on top will cancel out with that 2 on the bottom. And we're left with 5 times 3, which is just 15. And then on the other side, because 5 times 2 is really just the same thing as 10, that whole 10 cancels out with the 5 and the 2. And the only thing we're left with is just the original numerator part, just 3x. So notice that now we have turned this problem into a much simpler equation than the one that we started with. We got rid of all of those denominators. It's not as crazy with all of the fractions. And so now we're just going to finish solving the equation like we normally would. So in this case, let's think about getting all of the x's together on one side. And then here, let's just divide both sides here by -5. So we get a final answer that x must be equal to -3. All right, there's one last piece to the sentences up here at the very top. That is one final thing that we will check when we are finished solving. So once we're down to our answer, we are going to double check for extraneous solutions. So we could have an extraneous solution for this type of equation as well. The last time we saw this back in chapter 7, it could happen when we were solving those log equations, because we said we can't take the log of the negative. So sometimes we crossed out our solution and we called it extraneous. It's going to be similar on these because we cannot have any value that would make the denominator 0. And so in this particular case, we don't have an x on the denominator at all. And so this first equation wouldn't have anything extraneous. It's perfectly fine for x to be -3. The only position we're plugging it in is on the numerator, so that's good. But when it comes time for like the next problem, we do have an x down here on the denominator. And so we want to think about like what would those restricted values be. Like in this case, x cannot be equal to 0. And so that's a little something helpful to think about, even at the very start of the problem, so that if you go through all of the steps and you get to an answer, and then your answer ends up being something that is not allowed, if it would make the denominator 0, we're going to cross it out and just call it extraneous. It doesn't happen all the time, but it could happen. So it's just something we want to be aware of. All right, so in this next problem, let's think about starting the same way of identifying our least common denominators. So we want to find all of the factors that are represented in all of the denominators. Let's first notice here that we have an x, and the most number of x's in a single denominator is just 1x, so you only need 1x in the LCD. Also, it looks like we have a factor of 3, but the most number of 3's in a single denominator is just 1 3. So it looks like our LCD will be 3 times x, if we just switch the order around. And we want to think about multiplying everything on both sides by 3x. And I'm going to do the same thing I did before in the other problem of splitting up this left-hand side. So it's really 3x over 1 multiplied by the first term, which was 3 over x. I'm going to bring down the subtraction sign, and then just do it again. 3x over 1 is going to multiply by the second term, the x plus 21 over 3x. And then we'll do the same thing over here on the other side of the equal sign. That 5 over 3 will also multiply by 3x over 1. All right, so now we get to go through and do some canceling on each part, and we'll see what we're left with. So in this first part here, notice that the x on the top is going to cancel with the x on the bottom. And this is leaving us with 3 times 3 on the top, so that's just 9. I'm also going to go ahead and bring down the subtraction sign. All right, in the middle one here, it looks like the 3x on the top completely cancels with that 3x on the bottom. Now, it's going to leave us with the x plus 21, but notice how it's behind a subtraction sign. And so for a moment, I'm actually going to leave that x plus 21 in parentheses, because both of those terms are going to be subtracted. We're not just subtracting the x, we're also going to be subtracting 21. And then let's see what's happening here on the other side. It looks like it's just the 3's that will cancel on the top and bottom, so that's going to leave us with 5 being multiplied by x, so we still have 5x on the other side. All right, I'm going to go ahead and distribute that subtraction sign. At this point, we have just a much simpler equation here that we can solve how we normally would. Let's combine the like terms here. 9 minus 21 will be negative 12. If we go ahead and add x to both sides, we get that negative 12 is equal to 6x. And then dividing both sides by 6 here, we can see that our final answer is that x is negative 2. All right, and because that was not one of our restricted values, we did not end up getting x equals 0. We don't have any extraneous solutions. That just is our solution. It's totally fine here if you plug in negative 2 for x. It's not going to cause the denominator to be 0. All right, there's some different kinds of denominators that we will see, and so let's take a look here at our next problem. Kind of similar to a lot of the problems that we were doing last week. If you notice that you have a denominator that can be factored, let's go ahead and factor that denominator first. So it looks like this x squared minus 9, that can turn into a difference of squares. So we can factor it into x minus 3, x plus 3. If we put some parentheses around the other denominators that were already there, notice that we have some things in common. So our least common denominator, it has to have an x minus 3 in it to get that part canceled. And then it also needs to have an x plus 3 in it. So we just want to have every different factor represented so that it's enough to cancel everything in every denominator. Okay. This one is going to take a little bit more space to write out, but I'm going to write it out exactly the same way as I did before. So we're going to think about multiplying everything on both sides by the least common denominator. So here's the first part. It's always the least common denominator over 1. All right, so that takes care of everything on the left-hand side. And then we'll also multiply it on the right-hand side. So everything here in blue, that's just copying down the original equation. Everything here in green is just showing that we're multiplying everything on both sides by the least common denominator. In this case, it's x minus 3 times x plus 3. All right, let's start to go through and look at canceling. So if we go back here to the very first part, it's just an x minus 3 on the denominator. So we can cancel that with this x minus 3 up on the numerator. But let's look at what we're left with here. So we're left with 2x multiplied by the quantity x plus 3. Let's go ahead and distribute the 2x inside. So our full leftover part is going to be 2x squared plus 6x. All right, the next one here, this will be nice because everything in that denominator will cancel. And it's a plus sign here, so we don't have to worry about that subtraction sign going to both parts. So let's just bring down the plus sign. And we're just going to recopy that numerator part, so we still have 6 minus 2x. Then we're ready to put in our equal sign. All right, canceling on the other side, it looks like we can only cancel out the x plus 3. We're left with x times the quantity x minus 3, so let's distribute that, and that's going to get us x squared minus 3x. All right, so in terms of solving this equation now, it is a little bit more complex than the last one we did because now it's quadratic. So now we have an x squared in here. And so the approach for solving quadratic equations is to get everything on one side, get the other side equal to 0, and then try to factor. If for some reason you couldn't factor something, or it was hard to factor, you could always use a quadratic formula. But if you're able to figure out the numbers, factoring is maybe even a little faster. So that's the idea here. So let's go ahead and get our x's together on the same side, x squared. All the pieces on one side, yeah. I'm thinking we can move everything to the left. So let's maybe do that by a big line here. Let's go ahead and subtract x squared from both sides. And then we can also add 3x to both sides. So that's going to make our right-hand side here equal to 0. And then let's just go in order here. So when we do the 2x squared minus 1x squared, that's just 1x squared. Put that in the front. And then we'll have our x term go behind that. So we actually have 3x terms that we can combine together. So we've got 6x plus 3x, but then we're still subtracting the 2x on the end. So that'll actually be 7x. And then we'll just bring down the plus 6. All right, so now when we're thinking about factoring, we want our numbers to multiply to 6 and add to 7. So let's do 6 and 1. We get x plus 6 times x plus 1. And then to finish it out, we'll go ahead and set each factor equal to 0 and solve for x. So we end up getting negative 6 and negative 1. It looks like both of these answers are going to be just fine, because if we go back and look at the original problem, the only values that could make the denominator 0 would be if x was 3 or if x was negative 3. So those are the only restricted values. We did not get either one of those for our answer when we solved it out. So we don't have anything extraneous. We just have two answers, both negative 6 and negative 1. All right, let's go ahead and turn it over to the last side. There's just a couple other final things that could happen. All right, so on this next one, so same thing, looking at our original denominators. Let's look and see if there's anything that can be factored. So in this case, that right-hand side denominator factors into x plus 5, x plus 3. That's super handy for us because those are the denominators that we have in the fractions on the other side already. And that is going to be our least common denominator. So we need one factor of x plus 5 in there and one factor of x plus 3. All right, so that's what we want to think about multiplying everything on both sides by. So I'm going to start writing this out. So we've got x plus 5, x plus 3 over 1. And we'll multiply that by the first piece, which was 1 over x plus 5. And just go ahead and write this out for the second piece. I'm going to switch up the order a little bit on the other side. I'm going to put the LCD part in front, just to kind of stay consistent with the way I wrote the others. So every part in parentheses here represents that just came from the original equation. We're just putting that least common denominator over 1 out in front. And now we can start to go through and do some canceling. So back at the very start, it looks like the x plus 5 will cancel. And we're just left with x plus 3 times 1. So it's just x plus 3. For the next little part here, let's go ahead and cancel the x plus 3's. We do have 2 multiplied by the quantity x plus 5. Let's go ahead and distribute in the 2, so it's going to turn it into 2x plus 10. All right, everything in the denominator cancels over on the right-hand side. The only thing we had left in the numerator was -2. All right, now this one is back to a simpler equation to solve. So notice that we don't have an x squared. It's not quadratic, so we don't need to worry about factoring. Let's go ahead and combine some like terms on this left-hand side, though. So that whole thing is going to turn into 3x plus 13. And then we want to isolate the variable on one side. We want to get the number part all on the other side. So we get that 3x is equal to -15. And at the end here, we end up getting x equals -5. What's the problem with that answer? What do you notice, Bella? Yeah. How do we know it's extraneous?
This is going back to the original, there's like positive side in the denominator, so that would make it easier to do it.
Exactly. So this was actually one of our restricted values. At the very start, if we go back and look up here, between the x plus 5 and the x minus 3, well, in this case, x is not allowed to be -5 or -3, but -5 ended up being the answer we got through our algebra. So if this were the case, I still would like to see all of your steps leading up to that answer of -5, but here we can just cross it out, and we can write no solution. All right, so there's kind of that special case. That's something that we want to be careful of with these equations, is we never want the denominator to be 0. All right, so one last problem we're going to take a look at here. So one thing that's a little different is that we see something on the denominator on the left-hand side, but we don't see a denominator at all on the other side. So if that happens, you can actually write that as being a fraction over 1. You can always turn something into a fraction by doing that. And because it's just a 1, though, we don't actually have to do anything special with like having a 1 represented in the least common denominator. Like technically there could be an invisible 1 in there, but really we just need to think about like how are we going to get the other two denominator parts canceled out. And so we'll have to have both pieces represented in the LCD, so it's going to be x plus 1 times x minus 3. All right, now as you start to get better with this process and feeling more comfortable, you don't have to write out all of the steps in the same way that we've been doing. You could start to think about this like, okay, I know that every part is going to get multiplied by this, so just think about what's going to cancel when you multiply it by the first fraction. The x minus 1 is going to cancel out. You can think about that x minus 1 canceling, meaning that we still have an x minus 3 from the LCD, and then we still have an x minus 1 from the numerator. So it's kind of like this would be the result of multiplying the LCD by this. X minus 1's cancel, x minus 3 is left from the least common denominator, and then the x minus 1 is there from the numerator. All right, and then this one has a subtraction sign, so I'm going to bring that down. And then I'm going to do the same thing here for the second fraction. So in the second fraction here, I'm noticing that the x minus 3 from the least common denominator is going to cancel with the x minus 3 there. So all that's going to leave us is with a 6 from that numerator is going to multiply by the other part of the LCD that didn't cancel. That 6 is going to multiply by x plus 1. Now, on the other side, when this gets multiplied by the least common denominator, nothing is going to cancel because we do not have anything on this denominator that could cancel from that. And so we're just going to leave the 3 in front. We're just going to copy over that least common denominator exactly as it originally was. These no parts cancel from. So this is an option for you to think about what would cancel Think about that part in your head, and then we're just writing down the result. Now this one has a bit more work for us to do, because in order for us to continue solving, like we have to do some FOIL. On either side, it looks like we have the distributive property, so there's definitely some more steps needed to finally solve for x. So I'm just going to start to write out these pieces here of getting everything simplified. It looks like that first one is going to turn into x squared minus 4x plus 3. Distribute the negative 6 into the next part, so that takes care of that. There's a couple of options for how you can do the right-hand side. So you could FOIL these two parts together first, and then distribute a 3 into that answer. Or you could distribute 3 into the first quantity, and then take that and do your FOIL second. If you do that second option, though, make sure that you're only distributing the 3 into the first part. You're not going to also distribute it into the second part. So on mine, I'm actually just going to leave the 3 out of the front. It's easier for me to think about just doing my FOIL first, and I'm just going to save that 3 until the very end. So it looks like we FOIL this one. So I'm going to leave the 3 in front, but it looks like that ends up being x squared minus 2x minus 3. Then I'll go ahead and distribute the 3 at the end. So it's really going to be 3x squared minus 6x minus 3. Oh, minus 9. Sorry. Thinking about that too quickly. There's a lot of 3's in there. All right, we could put some like terms together on the left, so let's go ahead and just leave the x squared in front. But we can put together like the minus 4x minus 6x. So that'll be minus 10x. And then 3 minus 6 will turn it into minus 3. Okay, so that in itself took some work. But now that we have the parentheses gone, we combine like terms on both sides. Notice that we have the x squared in there again. So it's quadratic, so we have to get everything on one side and get the other side to equal to 0. All right, let's think about trying to get everything over here to this right-hand side. So we can do that by subtracting x squared from both sides. Let's also add 10x to both sides and 3 to both sides. And now we have the left side totally equal to 0. On the right side here now we've got 2x squared plus 4x minus 6. All right, and before we think about factoring this, let's take a look at a little trick here. So this 2 that's out in the very front, that 2 is a common factor between all 3 of the terms. We've got 4, we've got negative 6. Those are all even numbers. They can all divide by 2. So something that's going to make our factoring easier is to actually divide everything on both sides of our equation by 2. Part of the reason this works out really nice is because on the other side, 0 divided by anything is 0. And it's going to make our numbers smaller on the factoring side. So it's going to turn it down to 1x squared plus 2x minus 3. All right, now this is going to factor into x plus 3 times x minus 1. And when we set each part equal to 0 and solve for x, we get negative 3 and positive 1. So what's a little interesting about the final answers on this one is that they look close to the values that are restricted, but they're not exactly the same. So if we go back up to our original problem and look at our denominators here, notice that our restrictions are that x cannot be negative 1 or positive 3. So it's perfectly fine for us to have positive 1 and -3. So both of these answers are perfectly okay.